Hello, very good morning students. Today we are going to discuss Fourier series with the topic half range Fourier expansion. So let's start. It is a very important topic for the GTU. Any arbitrary function f of x with period 2l which is defined half of the interval 0 to l can also be represented in the terms of sine and cosine functions. A half-range expansion containing only cosine terms is known as half-range cosine series, and similarly a half-range expansion containing only sine terms is known as half-range sine series. So let's start the example of the cosine series and sine series, and before starting the example, the formula of the cosine series, that is, for the period 0 to L and for the period 0 to pi, the half-range cosine series is f of x is equal to a0 plus summation and 1 to infinity an cos n pi x by L, and for the period 0 to 2 pi, that is f of x is equal to here a0 by 2 plus summation n 1 to infinity an cos nx. For the a0 in the period 0 to L, a0 is here 1 by L, this one is 2 by L, 0 to L, f of x dx, and an, that is 2 by L, 0 to L, f of x cos n pi x by L dx. And for the period 0 to pi, a0 is 2 by pi, 0 to pi, f of x dx, and an 2 by pi, 0 to pi, f of x cos nx dx. So students, this is the formula of the cosine series for the period 0 to L and for the period 0 to pi. So let's start the example of the cosine series. Our first question is, find the half-range cosine series of the function f of x equal to x in the interval 0 to pi. Okay, as our given function is f of x is equal to x, our interval is 0 to pi, and we want to find the cosine series. Let's start the solution with the formula of the cosine series, that is f of x, here a0 by 2 plus summation n 1 to infinity an cos nx. Now the formula for a0, that is 2 by pi, 0 to pi, f of x dx. Now 2 by pi, 0 to pi, our given function f of x is x, and as per the rule, the integration of the x, that is x square by 2, and the limits are 0 to pi. So after substituting the limits of the upper limit, we have pi square by 2 minus 0. So after simplification, 2 will be cancelled, 1 pi will be cancelled, and the value of a0 is pi. Now the formula of an, that is 2 by pi, 0 to pi, f of x cos nx dx. Now 2 by pi, 0 to pi, our given function f of x is x, here cos nx dx. Now we are going to apply the rule of the integration of uv, that is here x, keep it same. Integration of cos nx is sin nx upon n minus the derivative of x is 1. Integration of sin nx, that is minus cos nx upon n square, and the limits are 0 to pi. So after substituting the upper limit and lower limit, here sin n pi is 0. So after substituting upper limit, my first term is 0. This is minus minus plus. After substituting pi into second term, that is cos n pi, and value of cos n pi is minus 1 raised to n upon n square, minus, after substituting the lower limit, again 0 into anything is 0. So if I replace this x by 0, my first term is 0 after replacing my second limit, and this minus minus plus, cos 0 is 1, so 1 upon n square. So after simplification, 2 by pi, here minus 1 raised to n minus 1 upon n square. So this is the value of a n. Now I am going to substitute the value of a0 and an in this equation 1. So my cosine, half range cosine series is f of x is equal to value of a0, that is pi, and here pi by 2, okay, plus summation n 1 to infinity. Now the value of an, that is 2 by pi minus 1 raised to n minus 1 upon n square. So here 2 by pi minus 1 raised to n minus 1 upon n square into cos nx. So this is the formula, or we can say that this is the result of the half range cosine series. Okay, now if we take n as even term, then this minus 1 is converted into the plus 1. So for every even, our this answer is 0. Okay, so for odd term it remains only, so pi by 2, plus for odd term this minus minus plus, and this minus 2 minus minus 2, this one is minus 4 upon pi, and here after substituting and 1 3 5, that is cos x upon 1 square, then plus cos 3x upon 3 square, plus cos 5x upon 5 square, up to so on, because for every even n the second term will be 0 here. Okay, so this is the final half range cosine series for the given function. Now the example 2 for the cosine function, that is here, find the half range cosine series for f of x is equal to pi minus x in the interval 0 less than x less than pi. So as per the rule, students, the formula for the half range cosine series, that is f of x is equal to a0 by 2 plus summation n 1 to infinity, as our limits are 0 to pi. So here we have an cos and x. Now let's start with the formula of a0, that is 2 by pi 0 to pi f of x dx, and our given function, that is f of x is pi minus x. So we are substituting here pi minus x dx. And the integration of this pi with respect to x, that is pi x, and the integration of this x is x square by 2, and the limits are 0 to pi. So after substituting the upper limit and lower limit, here 2 by pi, so here pi square minus pi square by 2, this is the result of the upper limit, minus, after substituting lower limit, both term is 0 here. So this is pi square minus pi square by 2, so we have pi square by 2, and this 2 will be cancelled, this pi also cancelled, and here our answer is pi. Now let's move with the calculation of an. So the formula of an is 2 by pi 0 to pi f of x cos nx dx. So 2 by pi 0 to pi, value of f of x is pi minus x cos nx dx. So we consider pi minus x as a u and cos nx as v. So we keep pi minus x, keep it same. Integration of cos nx is sin nx upon n minus the derivative of this pi minus x is minus 1. Integration of this sin nx is minus cos nx upon n square, and the limits are 0 to pi. So after substituting upper limit in the first term, this pi minus pi is 0. So our first term is 0. 3 times is minus here. So minus cos n pi, that is minus 1 raised to n upon n square. This is the value of the upper limit. After substituting lower limit, this pi minus 0 is pi, but sin 0 is 0. So here 0 minus cos 0 is 1. So 1 upon n square. This is the value of the lower limit. So after simplification, our answer is 2 by pi. This is minus minus plus. So 1 minus minus 1 raised to n upon n square. We are going to substitute the value of a0 and an in equation 1. So substitute value a0 and an in equation 1, that is f of x is equal to a0 is pi, so pi by 2, summation n 1 to infinity, value of an is 2 by pi 1 minus minus 1 raised to n upon n square. So here 2 by pi 1 minus minus 1 raised to n upon n square into cos nx. So dear students, this is the half range cosine series for the given function pi. Let's take one different example for the cosine series, that is the exponential function. So let here example 3, find half range cosine series of f of x is equal to e raised to minus x in the interval 0 less than x less than equal to pi. So let's start the solution. Here our formula for the cosine series is a0 by 2 summation n 1 to infinity an cos nx. Now let's start with the formula of a0, that is 2 by pi 0 to pi f of x dx. Now 2 by pi 0 to pi. Here given function f of x is the exponential function, that is e raised to minus x dx. Now the integration of this e raised to minus x is e raised to minus x upon minus 1. So I put here minus, and limits are 0 to pi. So after substituting upper limit and lower limit, if I take this minus outside the bracket, so I have a0 is equal to minus 2 by pi, and after substituting upper limit, I have e raised to minus pi minus e raised to 0. So here e raised to minus pi minus e raised to minus 0, and e raised to minus 0 is 1. So minus 2 by pi, here e raised to minus pi minus 1. So if I take minus common from the bracket, then my answer is 2 1 minus e raised to minus pi by pi. Okay, so this is the value of a0. For an, my formula is 2 by pi 0 to pi f of x cos nx dx. Okay, so if I substitute the value of f of x in an, that is an equal to 2 by pi, here 0 to pi e raised to minus x cos nx dx. So as per the formula of e raised to ax cos bx dx, so the integration is e raised to ax upon a square plus b square, and in the bracket a cos bx plus b sin bx. So I am applying this formula for this given function, that is e raised to minus x upon minus 1 whole square plus n square, and in the bracket minus 1 cos nx plus n sin nx, and our limits are 0 to pi. So see, this is the generalized formula. Now I am going to apply the upper limit and lower limit. So 2 by pi. After applying upper limit, here I have e raised to minus pi upon 1 plus n square cos n pi, that is minus 1 raised to n. So minus 1, here minus 1 raised to n, sin n pi is always 0. Okay, so this is the value of the upper limit. After substituting lower limit, e raised to minus 0 is 1. So 1 upon 1 plus n square. Here cos 0 is 1, so minus 1 into 1, so just minus 1 plus sin 0 is 0. So this is the value of the lower limit. So here 2 by pi minus 1 raised to n e raised to minus pi, here minus plus 1 upon 1 plus n square. So I represent this term as 2 by pi 1 minus 1 raised to n e raised to minus pi upon 1 plus n square. So this is the value of an. Now I am going to substitute the value of an, a0 and an in equation 1. So substitute a0 an in equation 1. So our equation 1, that is f of x, and value of a0 is here 2 by pi 1 minus e raised to minus pi. So here 2 by pi 1 minus e raised to minus pi whole by 2, right? Plus summation n 1 to infinity, and value of an is 2 by pi 1 minus 1 raised to n e raised to minus pi upon 1 plus n square. So here 2 by pi 1 minus 1 raised to n e raised to minus pi upon 1 plus n square into cos nx. So after simplification, this 2 will be cancelled. So here 1 minus e raised to minus pi by pi, and if I get 2 out of the summation, that is 2 summation n 1 to 2 by pi, both are constants. So here summation n 1 to infinity 1 minus 1 raised to n e raised to minus pi upon 1 plus n square into cos nx. So this is the Fourier series expansion for the given function, exponential function e raised to minus x in the given integral 0 to pi. So students, today we learn about the half range cosine series. Feel free to contact me for any query. Till that, enjoy the study. Thank you.